All right, let's jump right into this. Welcome to today's Explainer. We're diving straight into a really fascinating and honestly super practical area of math today. We're going beyond just counting on our fingers. Our focus? Beyond zero, addition and subtraction with integers.
So to set the stage, picture a massive mountain soaring up into the sky, and right below it, the deep, dark ocean. Right there in the middle, at sea level, that's our baseline. That's zero. And this is the perfect way to anchor how we think about integers. You see, they aren't just random numbers floating around in space. They represent exactly where we are relative to that baseline, stretching out infinitely above us and infinitely below.
And that actually brings up a huge kind of philosophical question from our source material. How do humans use numbers to understand existence? I mean, it's pretty mind-blowing when you stop and think about it. So today, we're going to decode reality. We'll see exactly how we use these numerical tools to make sense of the world around us.
Here's our quick roadmap for the explainer. First up, beyond zero. Second, integers in real life. Third, the golden rules. Fourth, 4 basic properties. And finally, the human mind and math.
Okay, let's kick things off with Section 1, Beyond Zero, Integers.
Let's transition from the physical world into the abstract ideas that kind of govern it all. What are integers? Basically, they're a set of numbers that includes positives, negatives, and zero. But, and this is a big but, these aren't just boring symbols stuck on a whiteboard. They are totally practical, everyday tools. We use them all the time to measure opposite states in the real world. Think gaining and losing money, moving up and down, or hot and cold temperatures.
Which brings us nicely to Section 2, integers in real life.
Like I said earlier, we're going on a vertical journey today. We're talking mountain peaks to ocean trenches. Check out this contrast. On one hand, we've got Osman. He's this avid mountain climber scaling some serious altitudes. On the other hand, there's Daphne, an adventurous deep-sea diver plunging into the ocean depths. Positive altitude versus negative depth. Now, what's really interesting here is that even though they are exploring in completely opposite directions, their locations are handled by the exact same mathematical concept.
Let's tag along with Osman first. According to our source, he starts his climb at an altitude of 540 meters. He's pushing upward, specifically hunting for this regional saffron plant. And when he finally spots it, he's all the way up at 1,250 meters. I want you to literally visualize this. Picture a vertical number line in your head. Osman is just moving continuously upward, right in that positive direction. Every single step adds to his elevation, putting him firmly, unequivocally in the land of positive integers.
All right, let's switch gears and head underwater with Daphne. She's on a mission to find a sunken plane wreck. She starts by diving 15 meters down. No plane yet, so she goes 10 meters deeper. Think about this as a quick math problem. If down is our negative direction, she hits negative 15 and then tacks on another negative 10 to her depth. Any guesses on her final depth before I give it away? Well, if you said 25 meters down or a depth of negative 25, you hit the nail on the head.
Now for Section 3, the golden rules of addition.
So, we're shifting from physical exploration to the absolute rules of the math game. And honestly, don't sweat it. If you were able to track Osman and Daphne, you already know how to play. Let's break down these 2 main rules. For the same signs, super easy. You just add their absolute values together and keep the common sign. Now, for opposite signs, it's slightly different. You subtract the smaller absolute value from the larger one, and then you just keep the sign of whichever number was bigger in absolute terms. I promise, these aren't just arbitrary rules. They're just logical extensions of our climber and diver. Let's look at the same signs rule with a really relatable example from the text. Imagine Aisha is at school. Her classroom is on the 2nd floor, so let's call that a positive 2. She decides to head up to the library, which is 3 floors straight up. That means we're adding a positive 3. Positive 2 plus positive 3 equals positive 5. She steps out onto the 5th floor. Because both numbers are moving in the exact same upward direction, their forces just combine seamlessly. Makes sense, right?
Now, I know adding opposite signs can trip people up sometimes, but let's just walk through it with these 3 steps. Step 1. Find the absolute values. That just means look at the numbers without the plus or minus attached. Step 2. Subtract the smaller value from the larger one. Step 3. Apply the sign of the number that had the bigger absolute value. So, the crucial point is, whichever number has the most weight, the biggest absolute value, that's the one that dictates the final sign.
Let's immediately put those 3 steps into practice with a classic scenario, paying off debt at the school canteen. Say Osman Efia owes 10 liras. Since it's a debt, that's a negative 10. He pays 7 liras.
Making a payment is a positive action, right? So that's a positive 7. Now we have negative 10 plus positive 7. The absolute values are 10 and 7. We subtract 7 from 10 and get 3. But since the debt of 10 was the larger absolute value, the negative sign wins the tug of war. His remaining debt is negative 3.
Moving right along, Section 4, 4 basic properties of the operation.
Okay, we are making great time here. We've got the rules down. Now let's look at the actual structural properties that make this whole system work so smoothly. Just like any good game, addition has a rule book. There are 4 main properties here: the commutative property, the associative property, the identity element, which, spoiler alert, is 0, and the inverse element. These are basically the laws of physics for math operations.
And this table right here brilliantly illustrates exactly how they function. Look at the commutative property up top. It shows that changing the order of the numbers doesn't change the outcome at all. Positive 7 plus negative 5 is exactly the same as negative 5 plus positive 7. You get positive 2 either way. The associative property is similar. It shows that how we group numbers doesn't change the result. Then there's the identity element, showing that adding 0 literally changes nothing. And the inverse element? Well, adding a number to its exact opposite, like a positive 3 and a negative 3, cancels everything out and brings you right back to our baseline, 0.
Finally, Section 5, the human mind and math.
Now, let's zoom way out. We're stepping back from the nitty-gritty of absolute values and properties and returning to that grand philosophical idea we talked about at the start. There's this profound quote from our source text. One of the greatest features given to humans is the ability to understand, analyze, and make deductions about entities and situations using numbers. What you should really take away from this explainer is that math is not just about calculating canteen debt or tracking an elevator. It's so much more than that. It is humanity's ultimate built-in tool for literally analyzing the reality of the universe.
Which naturally leads us with this final, genuinely provocative thought from the source. Has the ability to use mathematics and perform operations been given to beings other than humans? It's a wonderful, deep question to chew on, isn't it? As we get a handle on these integers, these brilliant little tools that let us decode the hidden depths of the ocean and the soaring heights of the mountains, we kind of have to marvel at human consciousness. Thank you so much for hanging out with me on this explainer. Keep exploring, keep learning, and definitely keep asking those big questions.